Welcome to Autism Mathematics, cherished viewers. I'm starting a new series titled Indices. Indices is in core mathematics and then at the same time elective maths. So I'm going to treat all of them. Where it is elective maths, I will let you know, and then where you need it in only core maths, I will also let you know. So let's start with the first part of this series. In this video, I'm going to look at definition, the laws and properties of indices, and how to use the laws and then the properties to simplify certain integral expressions. Okay, consider the following. If 2 is multiplying itself 3 times, how do we write it? You can write it this way: 2 times 2 times 2. So 1, 2, 3. So 2 is multiplying itself 3 times. What about 2 multiplying itself 5 times? So we have 2 times 2 times 2 times 2 times 2. In the same way, you look at 2 multiplying itself 10 times. So we have 2 times 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 2. 1, 2, 3, 4, 5, 6, 7, 8. 2 more times 2 times 2. So you just observe what we have done so far. See, as the number of times that the number multiplied itself increases, writing them down becomes a little bit difficult. So there should be a way of writing it in a simplified form. In the first case, if 2 is multiplying itself 3 times, we can write 2 to the power 3. So when this 3 here indicates the number of times 2 is multiplying itself. Now the second one, 2 is multiplying itself 5 times. So we can write it as 2 to the power 5. So this 5 here indicates the number of times 2 is multiplying itself. And the last one, 2 to the power 10. Instead of writing this long thing, you can write it as 2 to the power 10. So in short, in indices, if you have a number 2 raised to the power n, we call this one the base, and then this the power exponent or index. Yes, any of them. 2 is called the base, and then this is called the power or exponent or index. In indices, there are some laws or rules that guide us, and as a matter of fact, that's what we are going to use. So in all cases, the base should be greater than 0. That's A, B must be greater than 0. Let's look at the first law. A to the power m times A to the power n. The bases must be the same. So if the bases are the same, when 2 indices are multiplied, you add the exponent. So A raised to the power m plus n. Example, 3 to the power 4 times 3 to the power 2. We first check the bases. 3, 3. So all that we need to do is to add the exponent. So 3 to the power 4 plus 2, which is 3 to the power 6. Let's come to the second rule. A to the power m divided by A to the power n. Once again, ensure that the bases are the same. If the bases are the same, then when 2 indices are divided, you subtract their exponent. On the right hand side, A to the power m minus n. Example, 3 to the power 4 divided by 3 to the power 1. Since they are dividing and they have the same base, we can apply this law. So you have on the right hand side 3 to the power 4 minus 1, which is 3 to the power 3. You can simplify it though. So this will give you 27, but it's the same thing. when an indices is raised to a certain power, like a to the power m or raised to the power n, and what you do is you multiply the exponent. So a to the power mn. Example, 3 to the power 4 all raised to the power 2 will be equal to 3 to the power 4, then you multiply the times 2, and which is 3 to the power 8. Now this is a property. A to the power 0 is equal to 1. That is, any number raised to the power 0 is 1. You can even have 1000 to the power 0. This is the same as 1. Another property is here. A to the power minus m will be equal to 1 on a to the power m. So take note of this property. Example, 3 to the power minus 2 is the same as 1 over 3 to the power 2. Well, let's look at other properties of indices. The sixth one, a to the power 1 on n can be written as the nth root of a. Example, 3 raised to the power 1/3 can be written as the cube root of 3. Now, number 7, a to the power m on n can be written as, here the denominator will come here, and then the numerator will be the exponent. The nth root of a all raised to the power m, and you can still rewrite it as this. Example, 3 to the power 3 on 4 can be written as the 4th root of 3 all raised to the power 3. Yes, you can also bring the exponent inside. And then a over b all raised to the power m. Now, if you have this, you can split the numerator and the denominator like this. Yes. So a to the power m over b to the power n. Example, 3 on 2 all to the power 2. So we split it. 3 raised to the power 2 over 2 raised to the power 2. So when you simplify, you get 9 on 4. Then the next one, a on b all raised to the power minus m. Now this is the same as, per one of our rules, a to the power minus m can be written as a over a to the power m. So we simplify and then got b over. So this is the same as b on a all raised to the power m. So this is showing you how we arrive at this answer. So that is the process. So when you have a fraction raised to the power negative index, just interchange the numerator and the denominator, and then the power will be positive. Example, so 2 on 3 all raised to the power minus 2. Instead of going through this, you can rewrite it as, you interchange the numerator and the denominator. You have 3 on 2, and then the index becomes positive all over 2. So you get the same answer. The next one, AB all raised to the power m. This is the same as you split them. So it's just like a to the power m times b to the power m. And remember, you can, if you have this, you can also put them together and say ab to the power m. So 3 times 2 all to the power 3 is the same as, you split them, 3 on 3 to the power 3 times 2 to the power 3, which is 27 times 8. So you can even simplify. And then the last one, if you have a on b all raised to the power 1 on n, this is the same as the nth root of a. So we have about 9 or 11 laws and properties of indices. Now why this? Very soon we are going to use these laws and rules to simplify indicial expression. So this is all about indices. So if you forget any of the rules, simplification will become difficult for you. So I will urge you to go over the rules, the laws, and then the rules again, so that you be conversant with the laws and then the rules. So let's go further by using these laws to simplify certain expression. Okay, simplification of indicial expression. Now, simplify the following. The first one is 8 raised to the power 1/3. So, number 1, 8 raised to the power 1/3. Now listen, when you are given something like this, what you need to do is to ask yourself, how can I break the base into indices so that I'll be able to simplify? This particular question, there are so many ways of doing that. 1, let's break 8 into simple numbers. We can write 8 as 2 to the power 3, all raised to the power 3. And according to indices, when an indices is raised to a certain power, you multiply the exponent. So 2 raised to the power 3 times 1 on 3. So this will cancel that. So you have 2 raised to the power 1, and which is equal to 2. Or this same question, if you don't know that 8 can be written as 2 to the power 3, let's break 8 into simple numbers. We don't know, but let's do that and see what will happen. So 8 to the power 1/3. Now this is the same as 8 can be written as 2 times 2 times 2, all raised to the power 3. And from our definition, if a number is multiplying itself a number of times, for example, in this case, 2 is multiplying itself 3 times, so we can write it as 2 to the power 3, all raised to the power 3. And then we apply the laws. So 2, according to indices, 3 times 1 on 3. So 3 will cancel that. So we have 2 raised to the power 1, which is equal to 2. So let's look at number 2. 100 raised to the power 1 whole number 1 on 2. So 100 raised to the power 1 whole number 1 on 2. So this is the same as 100. Let's change this one to improper fraction. 2 times 1, 2 plus 1. So this is 3 on 2. Now, can we write this, break 100 into simple numbers? Yes, we can do that. 100 can be written as 10 times 10. Now, 10 is multiplying itself twice. So we can write it as 10 to the power 2, all raised to the power 2. And according to indices, if an indices is raised to a certain power, we multiply the exponent. So 2 times 3 on 2. So this will cancel that. We are going to have 10 raised to the power 3, and 10 raised to the power 3 is 1000. So let's look at the next one, third one. 32 raised to the power 2 on 5, and 32. So how do we simplify it? Well, we don't know. We can say 32 can be written as 4 times 8, all to the power 5. Okay. And then we are just breaking the number into simple factors. And 2 can be written as 2 times 2. 8 can be written as 2 times 2 times 2. So 2 is multiplying itself how many times? 5 times. So we can write it as 2 times 5. 2 raised to the power 5. As the law says, if an indices is raised to a certain power, we multiply them. So 2 will cancel that. So we have 2 raised to the power 2, and 2 raised to the power 2 is 4. Let's look at, now that I've given you the basis, I want you to look at the rest of the questions, pause the video, and begin to solve them now whilst I'm giving you the answer. Now the next one is 16 over 81, all raised to the power, so 4. 16 over 81, all raised to the power minus 3 on 4. Okay. Now 16 over 81, if you want to get away with this minus, according to one of the rules, we interchange the 81 and then 16. So you have 81 over 16, all raised to the power 3 on 4. Go back to the rules and you see what I'm talking about. And we have 81 can be written as 3 times 27, and then 16 can be written as 2 times 2 times 2 times 2, all over 3 over 4. So this 27 can also be written as 3 times 3 times 3, and then 2 multiplying itself 4 times can be written as 2 to the power 4, so over 3 on 4. And then this can be written as 3 is multiplying itself 4 times, so 3 to the power 4 on 2 to the power 4, all raised to the power 3 on 4. And then according to indices, we can write it as this 3 over 4, all raised to the power 3 on 4, and then 2 to the power 4, all raised to the power 3 on 4. That is, if you have a fraction raised to a certain index, you can split them. And this is 3 to the power 4 times 3 over 4 over 2 to the power 4 times 3 on 4. So 4 will cancel 4. So you have 3 on over 3 over 2 raised to the power 3. And 2 raised to the power 3 is 27 on 8. So this is 8 will go into 27 3 times, and then over 3 on 8. Let's look at the next one. So the next question, question 5, is 5 to the power 3 times 5 to the power 2 times 5 to the power minus 2 over 5 to the power 4 times 5 to the power 2. Okay, so let's look at the numerator. The bases are the same, 5, 5, 5, and they are multiplying. So one of the laws says when they are multiplying, you add the exponent. So 5, 3 plus 2 plus minus 2 over, at the denominator, the bases are the same, 5, 5, so we can add the exponent. So 5 raised to the power 4 plus 2. So 2 plus minus 2 will go to 0. So we have 5 to the power 3 over 5 to the power 4 plus 2 is 6. Okay. Now the bases are the same, but they are dividing. And one of the laws says when they are dividing, you subtract the index. So 5, 3 minus 6. So we are going to have 5 raised to the power minus 3. That's 3 minus 6. And this one we can write it as 1 over 5 to the power 3. Now what is 5 to the power 3? 1 over 125. Good. Let's look at the sixth one. The sixth one is 256 to the power minus 1 over 4 times 2. So the sixth one, we have 256 raised to the power minus 1 over 4. Now let me tell you a secret. Look at the exponent. The denominator is 4. So you ask yourself, can I express this 256 in terms of a number which will give me an exponent of 4? Well, obviously 4 times 1 over 4 will cancel out. Can we have something like that? Yes, we are fortunate. We can have 4 to the power 4, all raised to the power minus 1 on 4. And then once again, 225. You ask yourself, can I express 225 in terms of a number which will give me an exponent of 2? And this 225 can be written as 15 to the power 2 to all raised to the power 1 on plus. Any number raised to the power 0 is 1 according to one of them. So this 4 will cancel 4. So we have 4 raised to the power minus 1. And then this 2 will cancel 2. We have 15 to the power 1 plus 1. And 4 to the power minus 1 can be written as 1 over 4 times 15 plus 1 is 16. So 4 will go into 16 4 times. So we have 4. Now cross check with your answer. If you got them all correct, that is a good start. If you couldn't, don't worry, go over it, go over the laws on the properties, and very soon you will get them right. Yes, I have introduced something called test your understanding. So I want you to try this set of questions. The answers are provided at the bottom. Simplify each of the following 48 times. Yes, so try these ones and then you compare it with your answer. If the details you have problem, you can let me know and I will give you a response. Viewers, thank you very much for watching this video. This is just the beginning. As I told you, we were looking at the laws and then the properties. We have more for you, but I will urge you to go over the laws and then the properties, because that's what we are going to use. In case you are watching me for the first time and you have not subscribed, just click on the subscribe button. You can also turn on your notification button so that anytime I drop a video, you can easily get it.